Welcome back, everybody. Today we are taking a peek at a pair of triangles with the idea behind our lesson that we want to show that these triangles are congruent to each other. What we're going to use to show that these two triangles are congruent to each other is a definition we discussed in class. So this video should be used as review or further explanation. We are going to discuss the definition of congruent polygons. The definition of congruent polygons states that two polygons are congruent if and only if their corresponding angles and corresponding sides are congruent to each other. Now, in a layman's way of thinking about that would be to say, if you can take a pair of polygons, in this case in our example triangles, and you can reorient them such that the angles that are in the same position and the sides that are in the same position are congruent to each other, well then the resulting polygons, those two triangles, they have to be congruent, and that should make perfect sense. So what we're going to do is we're going to investigate whether or not we can state that these triangles are congruent. In the margin here, you'll notice we have all the segments listed already. And the reason we have that is because it gives us it tells us the units in length that they are. So I'm going to go ahead and select AB first. AB is 3.61 units long. Its partner, in this case, would be DE, also 3.61 units long. So we could state that AB and DE are congruent to each other. Good start, right? A pair of sides that could possibly correspond, they're congruent to each other. So if that could hold true for the rest, we're good. Well, if you look at the margin, you kind of already have a spoiler, right? Segment EF, if we're going in letter order, would correspond to BC. And they're both 3.1 units. And then our last segments, AC and DF, are 2.51 units. So every corresponding segment is congruent to each other. So we're on the right track here. The only thing we would have to investigate now is some angle measures. So let's get some angles on the screen now. So here we have one angle. Looks like it's 43.06 degrees. I'll move that around in a moment. Another angle, 57.56 degrees. Really what we're looking to show now is the angles that would correspond with those segments we discussed. So A should go to D, based on those segments earlier. B should go to E, and C should go to F. Those angles would need to be congruent for us to meet the definition of congruent polygons to prove that triangles are congruent to each other. So let's take a peek here. Let's create some more angles. 43.06. All right, let's take a look at those angles loud and clear. We had 79.38, very good, 57.56, and 43.06. All of our corresponding angles match. So the angles that correspond A to D, B to E, C to F, they correspond, and all of those angles are congruent. So when you look at these two triangles, all of the segments that correspond are congruent to each other. All of the angles that correspond to each other are congruent to each other. The resulting polygons are also congruent. Now the definition of congruent polygons goes in both directions. If I know a pair of triangles are congruent to each other, then I could start identifying which parts have to correspond based on the statement. The other way around is to say if I can prove that all the parts of these triangles that are corresponding are congruent, I can make a statement saying the triangles are congruent. The definition of congruent polygons is, of course, biconditional. All right, hope this is helpful to go along with your notes. Thank you.